Can everyone see my screen?
Yeah.
Yes.
Okay. Started. Yeah, Igor, can you give us an update?
Sure. I worked with a way of putting the data I calculated before, how best to get it in the right place. I think I have a solution now. So it should be in PR like tomorrow morning, something like that. And after this is finished, I finally can start to think on what to do with parallelizing. Yeah.
Okay. Sounds good. Yeah, Alex, can you give us an update as well?
Yes, sure. So I worked on the changing the refund to transfer in the delete account action, and I expected to do this on the contract VM side. Expected to be fast, but I encountered the balance checker error again, and it took a long time to figure out what's happening. In the end, the explanation was quite simple. The logic on VM side created a receipt with the delete account action, so I had to pay for something like an execution of this receipt, and then for additional transfer fees, like complex formulas for fees for both implicit and explicit account. And after this, it worked, and now I'm working on the pull request, on the review, and when we finish it, I will finally start work on the storage for contracts.
Mm-hmm. Have you checked whether there is some issue with the documentation, the spec on the fees?
So actually, not yet. It's it's not about the issue. It's just that.
Well, yeah, not necessarily issue, but
something-
suboptimal maybe, or could be better.
So I think so, but I can't say exactly what's the problem. Maybe it would help me to understand that the VM is creating receipts in the very end. So for a long time, I thought that maybe I'm like not adding fees in the correct places. I should add fees somewhere else. But when we found that it's just about creating receipts, then it became simpler.
Okay, maybe let's take a brief look at this. So the one that I was talking about is this file, right? So it seems that you're suggesting that being more clear on where exactly the fees are charged could help in your case.
Yeah, maybe. So as far as I understand, on the VM side, they are charged like only, I guess, just before I didn't promise. And this is like the only place. So yeah, it might help.
Okay, do you want to like add that part to maybe this file or different files?
Is there any file describing the VM logic actually?
VM logic, yeah, probably not.
Maybe it
Yeah,
was another good thing to add, because I don't have a solid understanding what a promise is.
I see. Yeah, I don't think there's any the spec on VM logic. Yeah. Yeah. So feel free if you want to work on that. Let's maybe we can definitely. Binding spec. Yeah, I think those are just low level APIs. Yeah. Okay. Yeah, I think we can talk about how we want to work on that. Yeah, if you want to add the spec for VM logic, we can definitely do it.
Okay, so I can do a pull request to the NEP repository, right?
Yep.
Okay, will do.
Okay, sounds good. Yeah, I think we have something on the agenda here. Okay, yeah, I think last week we kind of briefly discussed the topic of global storage for contract code, and I think Evgeny had some different ideas on how this, on whether this is actually a good idea to implement. So maybe it's a good time to talk about that, because if we were to implement this, it's going to be a quite significant effort that involves changes not only to runtime but also to chain as well. Yeah. So Evgeny, do you want to talk about your objections?
Well, my objections is that it will reduce opportunities for scaling. So currently we don't scale very much, but once we have many shards, we want to scale, and global storage is a part which doesn't scale. Like, everyone needs to have it. And I think here you have some other things listed, like having multiple contracts in one account. I think this is completely unrelated to global storage, independent. And well, what I know that currently our toolchain for compiling contracts is very inefficient in terms of the size of the contract bytecode, and I think we should try to optimize that instead, like spend some effort. So we already know many places that we can optimize. We know that we are using std, which uses a lot of space. We are using serde, which uses a lot of space. And so I think we can, if we already reduced storage cost, and now it's much cheaper than it was some time ago to store anything, including contract code. And now, to reduce the cost of storing contract code specifically, we can actually reduce the size of compiled contract code. And if you compare it with Ethereum contracts are very small, like they have hard limit of 24 kilobytes for the contract. And usually, like, it's not a problem for contract developers, because usually compiled contracts are much smaller. And I think our contracts could be also have a comparable size to Ethereum contract if we invest some effort into actually optimizing this.
Okay. I mean, I think that's definitely something we can, and I think we're actually doing that. But I think the point, let's say actually, for the sake of it, let's say we optimize all that, and when we're not using STD, we get rid of Thursday, we implement our own JSON serializer or whatnot, and maybe the contract size is now 30 kilobytes, let's say. On the cost side, it might not be a problem, but I feel like for factory style contracts, it's still, well, cost is one thing, right? But another thing is that the amount of state it populates. It seems to me that we're unnecessarily duplicating that. Like, let's say you have a factory style contract and people call it, let's say, 10,000 times. Essentially, you're duplicating the same contract 10,000 times in the state.
Do we ever have other cases on Ethereum when someone creates 10,000 copies of the same contract?
I'm not sure. I don't know Ethereum very
If
well.
there is no such cases on Ethereum, then maybe it won't happen on Near, at least in the short term, because they probably won't like just invent that kind of use case out of nowhere. Well, in Ethereum there is approach to reducing the code size for multiple copies. They use proxies and delegate call to reuse the same code for many contracts. In Near, we don't have anything like this, although we can think of maybe if there is that kind of duplication between many contracts, maybe there is some small part, there is some part that is rarely used, and then it can be somehow maybe extracted into a single contract and then called from all those contracts.
So regarding use case, we're already seeing that today, right? So today, at least I know about two use cases. One is multiple actually. So one is the staking pool factory, so essentially all the staking pools today are deployed through factory. You might say there's nowhere near 10,000, which is definitely the case.
I think there is, given that we have currently like 60 validator seats, you're certainly not going to have too many staking pools. Like it makes no sense to run a staking pool if it doesn't get at least one seat.
Yeah, but the actually deployed ones are definitely over 60. I think there are several hundred because people do. I mean, they even though they may not have that amount of tokens to get a seat, they hope that, for example, they can get some delegations and whatnot. But okay, let's maybe not dwell on this example. So some other example include like the Near Foundation is developing this lockup factory, which is a factory contract that deploys lockup contracts for people. And there, I think they may potentially rely on that to deploy a lot of them. I don't know the exact number.
Well,
but
I think in all those examples, the contracts should be pretty small. They have little logic in them. So if we remove all the bloat, only have the code logic. If we only have the code that actually implement the contract's logic, it should be not much.
I mean, this thing is pretty well. Okay, maybe it's hard to measure like how large it is, but I mean, this contract is, I wouldn't say it's small. There's quite some code there, but it's hard to say the exact size if we do all those optimizations. So
actually, lockup in particular could be implemented in just one contract instead of a factory, like have one contract that is responsible for all lockups.
All lockups.
Because why split it between, like, why hold different lockups in different contracts? We can have one contract which implement all this logic and holds lockup for everyone. For pool, at least currently, I think it's not possible for one account to stake with multiple validator keys. So we need multiple contracts, although I think they could be fairly simple.
Okay. I think another, yeah, go ahead.
Well, we have, for example, bridge tokens. Also, a token, basically bridge token, it's almost like a plain token, so not much logic as well.
Mm-hmm. Okay. Yeah, I want to mention other use cases. Actually, one of the partners, they have the
comparable Ethereum contracts to see how big they are. So, for example, our implementation of our token shouldn't be, if it's well like optimized, it shouldn't be much bigger than implementation of an Ethereum token like ERC20. So, if it's much bigger, then it's probably not optimized enough.
Interesting. Oh, but I think another thing is that if we implement some contract, factory style contract, right? We shouldn't always expect developers to spend like a ton of time on like optimizing the contract they're going to deploy through the factory.
I think most of the optimization are not in the developer's code, but in our tools, like having built tools, for example. Solidity developers don't have to optimize that much for site. The compiler just produces small contracts for them.
Okay. Yeah, that's a good point. Maybe we can discuss. We can try to understand more about the use case offline.
Maybe in the long term, we want to optimize this anyway, because even if a contract is unique, we still want it to be cheaper. And reducing storage cost is not sustainable. Like if we reduce it too much, we can get too much data stored on chain.
Yeah. So also, regardless, what do you think of? I don't know whether you've read this, right? What do you think about the idea of not having this global shard, but for each shard you can store the contract code only once?
Well, it's a problem because we want to be able to dynamically reshard. So if we somehow incorporate this into cost, then we won't be able to reshard. We want to be able to arbitrarily reshard, like potentially even as much as like having each account in a separate shard. So we shouldn't depend on having some specific accounts in the same shard. So if we want to incorporate it into cost, like pay less for repeated copies in the same shard, then it's not good, because we want to be able to split this shard into multiple shards, and we want this to be transparent to users, so it shouldn't affect any visible costs for them. And if it's not reflected in the cost, then why do it at all? I mean, users are going to pay the same either way.
Wait, I don't understand. Why does this depend on some specific account? If you do it in the same shard, the only thing you do is that you say that I can refer to a code hash, and this is something that the shard, everyone who checks the shard will understand.
Yes, but we want to reshard dynamically, so at the current moment, possibly this account is in the same shard as another account with the same code, but then possibly we will split it into separate shard, and then we'll have to make another copy of that code.
So you're saying it's underpaid, or something like this?
Well, do you want it to make it cheaper to refer to existing code than to deploy the same code once again, like?
Yes. yeah,
Well,
that's
then it's a problem because possibly we later want to split this shard, so this code will need to be copied. So if a user pays less, then now it's underpaid.
yeah. I see what you mean.
So we want to be able to split the shards in any way we want, like we see that the shard becomes too big, we want to split it, and we want this to be transparent to users. So we don't want the users to see shards, to have to know what is in what shard. There should be implementation detail.
I see. Okay. Well, okay, maybe we can.
So it might happen that I like lost the discussion a bit. So I want to ask a question: like, is it about that we could create some guidelines for contract developers so that we may not need the special storage for duplicate contracts, or it's about something else?
Well, yeah, if King is basically saying that if we reduce the size of contract dramatically, yeah, we might not need this.
So what I'm saying, we want to reduce the size of compiled contracts. We want our tools to make smaller contracts, so we don't want developers to have to spend some significant effort optimizing their contracts for size. We instead want our tools to do it for them. And for Ethereum, there is Solidity compiler, which produces fairly small contracts. So I think the problem we have now is that the tools which we use, like Rust compiler, are not really designed for smart contracts. So they're not tuned for producing small binaries. So if we probably spend some effort actually like tuning, finding which, well, we already know some places where there is a lot of wasted space. And if we spend some effort, we can possibly find more such places and then optimize them. Then we probably can significantly reduce the size.
Okay, yeah, I will. Yeah, go ahead.
So is it possible that the final solution could be like avoiding the Rust compiler to WASM?
I think if we want smart contracts in Rust, then we need some sort of Rust compiler. Possibly it will be even somehow modified, but it still would be Rust compiler. And I think in general, Rust is a good language for smart contract. The problem is that current tools are not including like standard library, but in the long term will maybe have some replacement library that is specifically optimized to produce smaller code. But smart contract developers themselves shouldn't be required to spend too much time optimizing their code.
I see. Yeah, my point was that for me, Rust was a great starting point for trying to develop my own contract, and I mean, from my perspective, I would not like to study like any new languages. Like it's always simple to stick with the current one.
Yeah, I think we should also understand how much we can optimize, and yeah, but well, I still feel like it will be a problem when, even if the contract is 20 kilobytes and then we deploy a lot of the same contracts over and over again, it still will be a problem. It still is a kind of a concern for us. And for resharding, yeah, I think we can discuss in the chain sync on how more about sharding. Maybe, yeah, okay. Not talk too much here, I guess. Okay, I think we're almost out of time. Let's take maybe 1 minute break.